So in terms of your research, how does it benefit the wider community in KwaZulu-Natal?
So my community here will really benefit in terms of treating water, for example, even giving the best quality of water, drinking water. It might be even in medicine to treating cancer.
Hello and welcome to Ph.D. Hard Talk, Kanku Lubale. Thank you so much for your time and agreeing to have a conversation with me in regards to your research. Could you please take us through your research in your own words, and then we'll commence with the discussion.
All right. Actually, I'm working on the fluidization of nanoparticle. Nanoparticle are those particles with small sizes, sizes with nanometers. So we try to investigate their behavior in different applications, in industrial application, like in fluidization. It could be in wastewater treatment. It might be even in medicine, or even in biorefinery, biodiesel production. It could be in biohydrogen production. So nanoparticle nanotechnology is kind of like a new field that we try to link with the science. My research is more focused on the study of the structure of those small particles. Try to study the morphology, configuration of those nanoparticles, like shape, sizes, porosity distribution, to see how they behave in those applications. Because nanoparticles, when they are being synthesized, there is a big gap between synthesizing them and apply them in real life. They try to form agglomerates, and agglomerates are sometimes favorable in some other application and unfavorable in some other as well. So we need to understand how those agglomerates are formed, considering those forces like interparticle forces, van der Waal interaction, electrostatic interaction, capillary interaction, so that we optimize the proper size of those agglomerates to be used in any application. That is kind of like a summary of what I'm doing.
It's like, wow, okay. What does agglomerate mean?
Yes, agglomerate.
You don't know.
Agglomerate, it's that behavior of those small particles, they tend to combine together.
Okay.
They are nanoparticles. You can't visualize something with a 13 nanometer, for example.
Yeah.
I can give you a size of a sand. The sand, the small size grain sands, it might be 160 micrometer that you can visualize.
Yeah.
You can as well visualize nanometer, but they're quite very smaller. Now, when they are synthesized, they are in that small size, but they try to attract themselves. So there's those forces we call van der Waal forces, electrostatic forces. Because of the small sizes, they combine and form agglomerates. So agglomerate is like combination of those small particles. It extends, or they form like a grouping of the small particle together.
Okay.
Yeah.
So in terms of your research, how does it benefit the wider community in KwaZulu-Natal? Because I believe that's where you are.
Yes, exactly. My research will really benefit my community. Today, you know, energy and water crisis are really a major concern in Africa. And here in South Africa, for example, in the University of KwaZulu-Natal, where I have joined a nanochemistry research group, where students have been synthesizing many nanomaterial like nanocarbon, nanodots, nanotubes. There are so many types of nanomaterial they're synthesizing, and they try to link with the daily application. In wastewater treatment, for example, if you want to treat water, we want to remove heavy metal, we can use a nanoparticle. For example, in biodiesel production, we can use nanocatalyst, you know, as to improve the production of hydrocarbon. So my community here will really benefit in terms of treating water, for example, removing pollutant to wastewater, even giving the best quality of water, drinking water. we can still use a nanoparticle. Now, when we really understand their behavior in real life, it's become quite easy. They are quite complex, because you synthesize them, but you don't really know how they behave, how they really work in those different applications, like in wastewater. So my work, my thesis, or my knowledge will try to bring a very a well understanding of those nanoparticles and apply them in wastewater treatment, for example. It might be even in medicine to treating cancer. So yeah.
Oh, that's a big leap from wastewater to cancer. Like, wow, okay. So in terms of KwaZulu-Natal then, in terms of current situation, would you say there is a shortage of good quality drinking water? Is that what pushed you to conduct research?
Yeah, actually, when I had the topics on my MSc, it was not really implicating on the crisis in KwaZulu-Natal. That was the topics that I've been given by my supervisor. So I developed that thesis, that topics, until I get my dissertation done. Then on my PhD, I had to really work a lot on the applicability of my my topics to see how the real situation in KwaZulu-Natal, how my topics could link to the current crisis in KwaZulu-Natal. Yes, South Africa is facing a really big challenge in water sanitation. For example, we had a problem in water quality here in South Africa, in KwaZulu-Natal, the whole South Africa, I can say. And wastewater treatment is an area where we still need to emphasize, we still need to really work hard to have a good process in how to treat water. I think that really pushed me to really direct my research in that area. It's not only in wastewater treatment, it's as well in petroleum industry, because my field is in chemical engineering. And if we can really use nanoparticle in petroleum industry, we can have a higher production rate of hydrocarbon. Nanoparticle or nanomaterial can be used as a catalyst in a fluidized bed catalytic cracking, where hydrocarbon can be produced at a high quality, a high yield.
Okay. So in terms of, I hear what you're saying from the petroleum side and also in terms of water, which is stuff that we need on our day-to-day. In terms of your aim then, how are you going to get this information to policy writers? How are you going to ensure that this is implemented, that it's something that will be carried on? Maybe you might change your mind and say, do you know what? I'm done with research. It's not for me. How do you know that this will continue? Have you started working on an action plan? Where are you right now in terms of current thought and future situation?
Exactly. It's a good question. It's a good question. In the lab, when we start doing researches, we have to do what we call preliminary test, the preliminary experiment. So if I had my data on my lab, for example, I have a small scale of my fluidized bed, or I have a small scale of my data that I'm collecting in the lab, I can measure it. I can have a pilot test. The pilot test become like a scale up from the lab before I implement it to a big scale. So firstly, I will have to have my data that I have to see if really my nanoparticles are efficient to produce the desired product that I'm desiring. For example, in a water treatment, if I've got a waste of water which is not unclean, which is not clear, and I use it in treating water, and I realize that my water is quite treated, it's pure, and it's clear, then I can scale up to a big quantity. I can have a small wastewater treatment plant and test my nanoparticle in a big size and see if that works. And if that works properly, then we can propose it to the municipality, for example. That could be my suggestion. That could be the next step that I can do.
So you haven't thought of it?
No, from my result that I have, for example, how nanoparticle can be handled in industry using fluidization, because those nanoparticles are very small sizes of powder. they cannot move, they cannot be fluidized, you know, in a fluidized bed column. And industry are not using nanoparticle. Like, for example, in South Africa, they're quite very expensive. So you need to understand them. I've used a small size of a fluidized bed column with a size of 49 centimeters. And I managed to fluidize those nanoparticles. They can be fluidized if you modify that fluidized bed. So you use acoustic sound, for example, or you use vibration to it. So I've got data of that. And if any company approach me or they say, okay, fine, we've got this kind of issue, and then we want to produce maybe use nanoparticle in pharmaceutical, and we have maybe 1 ton of nanoparticle, and then we want to move it from one point to another point. Can you assist? Then I will sit down and design an equipment with the data that I have and be able to respond to their demands. So from now, what I can say, the data that I'm processing is on the lab scale, not in the industrial scale.
No, I fully comprehend and I understand what you're saying. I guess what I was trying to understand is, have you pitched this to, is it municipality?
Yes, municipality, KwaZulu-Natal in Durban, I think that it's a government institution where there's a different facilities, you know, of the KwaZulu-Natal, how they can deal with the issue of population around here.
So based on your response, the answer is no, you haven't, because you're still going through your pilot testing and you would love for a bigger organization to work with you. If they approach you, then bring it on, you will crack on. That's what
exactly. Yes, exactly. Because it's still on the institutional level. So it's just a project that we developed. We published them through article, or we present it through conferences or seminar. And if municipality are interested, then they can approach the institution, and from the institution can choose in my discipline, let's say chemical engineering, to see who's working in this kind of fields. Can you please come and solve this problem? Then I can come up with my ideas and put on table and solve their problem.
Okay, so that I understand clearly, your research now, since through development, is now focused on KwaZulu-Natal. So if we were to look at the sub-Saharan region and, you know, and expand, could it be implemented in, let's say, we'll say Mozambique or Tanzania? Is that something that can be done, or is it specific to one country?
Of course, it can be done. It's possible. All right. Now, South Africa, compared to some other African country, we can say it's got a little bit of infrastructure which are quite advanced compared to some other country. All right, because I'm coming from a DRC, Republic Democratic of Congo.
Oh, bonjour.
And, bonjour. And South Africa, yes, South Africa is just a place where I came to study, to do my undergrades and masters, and now I'm doing my PhD. And with what I have, I'm able to really implement it through other places, like in Mozambique, like Kenya, like Zimbabwe and others. The only factor that can could be maybe the cost of those nanoparticles. Nanoparticles are quite expensive. And what we can try to do is maybe to minimize the cost of producing those nanoparticles, and see if we can find any sustainable process in implementing them, you know, like in water, treating water in Mozambique, how we can have a similar process that the way that we have in South Africa, but in the cheapest way, you know, so that we give it for a benefit of the community. It's possible. We can do that. If we can do it in South Africa, we can do it in Mozambique, we can do it in Zimbabwe, we can do it in Congo as well.
And Malawi too, that's the neighboring country.
Exactly, yeah, exactly.
Why stop? No,
Yeah,
I understand. I guess I spoke to Dr. Jude Okole. I think he's the second person. If you want to go into his video, he's looked at
yeah,
using renewable energy sources to help.
yeah,
So maybe you guys can have a conversation, and you might
yeah,
come up with something brilliant, because he's
yeah,
looking at from an agricultural perspective in terms of
yeah,
when you burn all the vegetables that are left behind, and then you use that to reproduce electricity, etc. So he's your guy, maybe. So in terms of the challenges that you're facing in your research, you've
yeah,
mentioned cost. If we're hypothetically speaking, maybe we take Botswana because that's next door,
yeah.
and we say you want to go there, what does the cost look like to work on the same project?
All right, the cost in Botswana, that might be maybe the availability of material. All right. Yes, availability could be really costing. We've got facilities here in South Africa. For example, I'm not really specializing in synthesizing those nanoparticles.
Okay.
I'm specializing in using commercial nanoparticles,
Right.
but more into how to implement them in different processes, like in wastewater treatment. Now, in Botswana, we're going to see if we will be able to process those nanoparticles easily. Are we going to buy them from overseas, or are we going to make them ourselves? That could be the cost, you know.
Right.
In South Africa, at least, they synthesize that. I've been joining a nanochemistry research group where students are synthesizing those nanoparticles. It's become more cheaper, you know, and if they can do it in a big scale, so I can just take those synthesized nanoparticles and use them on my application. And if I will go to Botswana, and let's say it's a company that take me, or an institution, university in Botswana, are they going to have those facilities? Are they going to have all those equipment to synthesize them? If they don't have them, all right, so how can we get them? So we will have to maybe purchase them from a supplier, overseas supplier, or maybe in South Africa. That will be costly, you know. And maybe if the government will be try to reduce the cost, it may be by saying, okay, can we be able to synthesize them ourselves here?
Yeah.
Then that become more cheaper, you know, make them in Botswana and try to use them in Botswana as well. Yeah.
So in terms of advice, now we're looking at somebody like me who would want to study something similar to you. What advice do you have for them if they're coming from maybe the DRC and they're going to South Africa as well? What advice from the application process to working with the supervisor? What advice do you have?
Yes, chemical engineering is an exciting field. I like it and I enjoy it because it gives me freedom to solve complex problems.
Nice.
And I would really encourage young Black African to really put themselves into those kind of studies, because it's giving you some independency. You know, you become more informative in life and be able to apply it, you know, because you can apply it in different ways. It's not only in chemical engineering fields, but in economies, in banks, to just develop the whole continent, you know. And my advices will be, don't give up. And if you see that you are able to solve maths, you're good in maths and physics, you are a person who can handle pressure, who can work under pressure, who can take up the loads on you, yeah, carry on and take it and do it. Because at the end of the day, when you really have those skills of chemical engineering, you'll feel yourself be able to solve any problem. Yes, any problem in life, not only on your fields, but in life as well. Wow. So that could be my advice to you.
Amazing. So in terms of the application process coming from the DRC, and that's the Democratic Republic of Congo, going into South Africa, is it a smooth transition or is it quite difficult?
Yes, true. It's difficult. Firstly, I have to learn the language.
Hi.
Congo, when I came to South Africa here, I didn't come in on my youngest ages. I came when I was old. So my country is this French speaking. So I was speaking French, and I came in South Africa, I had to learn the language itself. So I had to spend 1 year learn English before I start my first year.
Okay.
It became a challenge, a very difficult situation where I have to adapt myself in learning the language first, adapt to society, the culture of the country, and readjust to the condition of the country itself before I get into my studies. So it's kind of like a learning process in different areas, not only in engineering side, but in life science, able to learn English faster, adapt to a culture, in South African culture, and continue with my curriculum. Yeah, it's kind of like difficult, yeah. But now it's fine because we're used to it.
Excellent.
Yeah.
So in terms of the application process then, what are the challenges when applying from the DRC, when you're still in the DRC, going into university in South Africa?
All right. DRC, when I left the DRC, I came here straight after my matric. So I had my matric, and then I spent 2 years working in one of the local industry in DRC, Vodacom. I'm sure Vodacom is in the UK as well.
No, I've heard of it. In Africa, I've seen it when I was in Africa. Yeah, so I'm aware.
Yeah, so I worked for Vodacom for like 2 years. Then I came here in South Africa after my work. So I did not do my university in Congo. So my experience at the university started here in South Africa, KwaZulu-Natal, in Durban. Yeah. So really experience at the university level, I have it here in South Africa rather than Congo. Yeah.
Oh, excellent. No, thank you so much for sharing. In terms of the next steps then, are you planning to attend any conferences, and what advice do you have for anybody that's wanting to go to a conference?
Okay, conferences, I will be attending one conference in December. I had one as well in September. So it's kind of like a busy year for me for conferences. I have some experiences in presenting in conference. That would be my 4th conference that I present my work. And the one in December, it will be a very big conference because the attendee, it's like 800 attendee. So the audience will be very big. And for those who really want to think of presenting their work at conference, yes, I will really push you, encourage you to always be able to present your work, especially your research work at the conference, because that way you had feedback, you had comments, suggestions, and questions from the peers. You have people are asking you about your researchers, and if there are errors, they can even correct you. And you can even measure yourself, how good you are and how do you have to perform for your next research work.
So in terms of well, I wouldn't say the most important thing. When you came to your methodology, how did you make a decision in terms of whether you wanted to focus on the quantitative ways or the qualitative, or go for mixed methods? What was your strategy and how did you make that decision?
All right. For my master's, for example, when I've been giving my topics to undertake my research work on fluidization of nanoparticle, they did not give me the material that I have to consider for my researchers. So my supervisor just say, okay, Tufan, you need to work on fluidization and sedimentation. That's all, that's what he gave me. So I had to sit down and do some reading, some literature review. After reading some literature review and see what material should I consider, what material should I select to attract, people, to attract my supervisor first, and that material should be able to be accepted by my institution. Then I had to think of considering nanoparticle. Nanoparticle are very sensitive and complex, in any application. Yeah. I chose that because I could be able to face those challenges as well. Yeah. So in qualitative side, nanoparticle have been chosen. So in quantitative ways, so I had to see what size of it that I could consider so that my output, my research output be beneficial in terms of research output to present to my supervisor and co-supervisor. Yeah.
So in terms of, I've looked at your abstract and I've read through your work as well. You've got some mathematical theory.
Modeling.
Yeah,
yes.
That you're working
modeling.
on.
Yes.
How did you get to that, and what is it for the wider audience?
Yes, no, I mean it's quite simple. If you in modeling,
we always to me.
we always refer to what is fundamental. When I'm speaking about two different particles with different sizes, plus and minus, there will be attraction, isn't it? Yes. That is simple. It's a high school principle. All the high school, they know that. So we develop our mathematical model from that principle. Okay. Hypothetically speaking, what I proposed on my researchers was if we had agglomerate forming, it means those nanoparticles were able to attract each other. If there's no attraction, then there's nothing will happen. The particle will be just dispersed, isn't it? And if they are forming agglomerate, it means there are some forces in between those nanoparticles. They might be positive or negative. If they were positive, and positive, there will be repulsion, or negative. So it should be opposite sizes. So from there, I will be able to model the forces in between those two particles, like van der Waals forces or electrostatic forces. And in terms of porosity, for example, if I have one big surface, a big cycle with a known radius, and in that cycle there's a little of a small cycle on it, I can be able to calculate or to measure the space that remain in between. It's a simple model, it's a simple model. So I will just gonna do that. I'm just gonna subtract the big size of radius, the big radius of the big cycle, minus the summation of those small cycle in that big big cycle. So those are kind of like fundamental that we use to model porosity, for example. And other model which I did perform was in fluidized bed, where I have opted the mass transfer in fluidized bed, where we have the mass conservation theory. If the bed of the nanoparticle are changing the height, the mass of those nanoparticles are not really changing. From there, I can just use the principle of those of mass balance and to model anything that I want. I can model the height of the bed. I can model the size of the bed. I can model the voidage in that fluidized bed. Yeah.
It must be
it's
nice.
Just there's no article here that I could show you how I do it, or maybe a screen where I could take my pen just to do it on the board. It's just an explanation. Yes.
No, that's perfectly fine. I'm with you. I understand what you're saying, and it sounds really exciting. That's why I said it must be nice to be a scientist, that you can play around with different atoms and particles to create what you think would work, and you can see the challenges behind it.
Exactly.
Complexities. So I have one more question to ask.
Yes. Okay.
And that question is, why did you say yes and agree to come on PhD Hard Talk?
Yes, I did. Yes. when I had that invitation saying if you can discuss your researches with us, I say yes. Firstly, I always want to, marketing my researchers. I always want to speak up on my researchers. And other thing is I will have my conference. I wanted to take that opportunity, to expose it, to explain it, because a good research is when you do it to someone who's not in the field and understand it. Because if I do my researches and that can only be understood by people on my field, it became complicated, it became complex. It should be able to be understood by other people as well who are not in the field. If you can understand it, which means I make it simple. It's complex, of course, it's complex, it's very difficult. But if you can understand it, then I'm able to make it simple. So I'm able to even apply it in the real life. So that's what I say yes.
Love it, love it. Thank you very much for that. So in terms of your time, thank you so much, Kanku Lubale, for your time. Remember, now we've got a new saying, which is hashtag project dissemination to the world. Share, like, subscribe, and if you would like to participate, get in contact with us on LinkedIn or on Twitter, or send us a direct message. All our details are on the YouTube channel. Thank you again for your time.
Thank you. Thank you. Thanks very much, and bye.